Hello there, it's Mr. Walton. What's going on, Science 10s? Today we're going to be talking about velocity, more specifically average velocity. Now, you might be a little bit confused right now, and I wouldn't blame you whatsoever. You might be thinking, well, Mr. Walton, we already talked about velocity. Well, we didn't. No, we didn't. We talked about average speed yesterday, and there's a really big difference. There's a subtle but big difference between speed and velocity. Here we go. What do you think is the same, and what do you think is different between speed and velocity? Now, I'm going to pull up the data booklet for Science 10, and let's take a look at what is the difference between speed and velocity. When I take a look at this, here I've got the symbol V for average speed. It's typically measured in meters per second. Okay. And then I go and look at the side and I see V with an arrow above it and it says average velocity, and it's typically measured in meters per second. Well, what is the difference between those two things? We've got a V with no arrow and then a V with an arrow. Okay, well, whatever. Let's take a look at the formulas over on the left-hand side. The first two formulas are exactly the same, except one deals with average speed and one deals with average velocity. Now remember, velocity, because it's got an arrow on top of it, that's a vector. It has a directional component. So where speed was the distance divided by the time, average velocity has to be displacement divided by the time. It's got to have a directional component. So let's go ahead and think about this. Speed is a scalar. It's got no direction. It is also the distance, the change in distance divided by the time, whereas when we take a look at velocity, it is a vector, so it has, yes, that's a check mark, yes direction. And I'm going to run out of room here. And so it is the displacement divided by the time. Okay, let's go ahead and let's kind of define this a little bit more thoroughly. So average velocity is we just talked about it. It is the displacement divided by the time over which the displacement occurred. Now remember, distance versus displacement. Let's take a look at something. Let's say I went oh, that's terrible. Oh man, whatever, that's okay. Let's say I went 10 meters to the left, and then I went, this is terrible, 15 meters up, and then I went 20 meters to the right, and then I went 15 meters down. I know that's complicated, okay? So if we were to do the distance for this example, we would just add up all of the, right, this is delta D. If we were to just do the distances, we would add up all the little mini distances. We would go 10 meters, that's what we did first, plus 15 meters, plus 20 meters, plus 15 meters, blah, 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 blah. So that's 10, 25, 35, 45, 55, 60. So 60 meters. None of them have directional components, but if we were to talk about displacement, we would have to add up all the directional components. Now what I'm going to do is I'm going to do the east-west versions first, or the left-right versions first, and we're going to see what can cancel out, and then I'm going to do the up-down or the north-south versions, okay? So we started going 10 meters, and that was in the west direction, and then I'm going to add, well, we went 20 meters east, and then in green, I'm going to go, okay, we went 15 meters north. It doesn't matter which order you do this in. 15 meters north plus 15 meters south. So now let's look at the reds, okay? So remember, the 15 meters west, that's like a negative, and east, that's like a positive. So what's going to win out here? Well, it sounds like we went 10 meters to the east overall, right? Or positive 10 meters. And then 15 meters north and 15 meters south. Do you see how those kind of cancel out? We went up and then we went down. It was kind of whatever, right? So the north is positive, the south is negative, and they just cancel each other out. So overall, the displacement went 10 meters east. So there's a very big difference between the distance that this object traveled and the displacement it traveled, okay? So the displacement is the difference between the start and the end. If I were to go straight from the start right here to the finish right here, I would have gone 10 meters to the east. Sorry, oh, that's terrible. But the distance we covered, that was the total amount of kind of area that we covered. Not area, but you know what I mean. So all these little distances added up, right? Okay, so now let's get back to the velocity formula. The velocity formula is v with an arrow equals delta d with an arrow over delta t. So the definitions are in your data booklet, but this is velocity, average velocity. Delta d with an arrow is displacement. And then delta t is time. So that's version 1, right? That's like the first version of the equation. Now, if I wanted to get delta d by itself, I would multiply by delta t. So I'd bring that up. The second version of the equation, delta d equals v times delta t. So that's the second version of the equation. And then third version, if I wanted delta t by itself, I'd divide by v. So this would kind of swing down. And I get delta t equals delta d arrow over v arrow. Oh, that's terrible. Oh, boy. Blap. Here we go. V arrow. Good. Not good, but you know what I mean. So we've got these three equations. Now, let's go ahead. I know this is the last time, I promise you. It's 12 seconds long. Calm down. It'll be okay. So let's go ahead and watch the video from yesterday or the last couple days about the blue and the red car. Okay, so we just watched the video, and let's kind of define some things here, or let's kind of illustrate some things. So the blue car, it went 1.3 kilometers north, right, in a total of 10 seconds. And the red car went all the way around, right, so 1.24 kilometers west, and then it went 1.30 kilometers north, and then it went 1.24 kilometers east. Oh, that's terrible. Oh, boy. So all in a total of 12 seconds. So let's go ahead and let's use this information to be able to calculate the average velocity of these cars. Okay, let's do the blue car. So the blue car, its velocity is determined by the displacement and the time. Its displacement, well, it went 1.30 kilometers north. Every time you write a vector, something with an arrow above it, it's got to have a number, its unit, right? And always a number goes with a unit. A number in its unit and its direction. That's what the arrow means. It's got to have a directional component because it's a vector. Okay, and it took 10.0 seconds. That's what we did yesterday. So 1.30 kilometers divided by 10.0 seconds is 0.130 kilometers per second in the direction of north. And remember, we turned kilometers into meters, so that was 130 meters per second north. Now that's insane. That's like so incredibly fast. Holy guacamole. Now let's do the same thing for the red car, right? The velocity is equal to the displacement divided by the time, but this displacement is quite interesting. What was that red car's displacement? It went 1.24 kilometers that way, and then 1.3 kilometers that way, and then 1.24 kilometers that way. I don't know if you noticed, but the west and east directions kind of cancel out, and it just went straight up. It just went straight north. At the end of the day, that's all it did. So its displacement, because they started and ended up in the exact same spot, its displacement is the same, 1.30 kilometers. And we kind of already talked about that on Friday. So it also went 1.30 kilometers north because the equal amounts west and east movement, they kind of cancel each other out. This time it went in 12 seconds. So when we do that calculation, we are going to get 0.108333 whatever kilometers a second north. And we're going to change that into 108 meters per second north. Now that might seem crazy to some people, because if I asked you which car had the greatest velocity, you wouldn't have said the blue car. The red car is traveling faster. But velocity average velocity is all about if you were to go straight from the beginning, straight to the end, straight from the start to the finish, on average, how fast and in what direction were you heading? That's what average velocity is all about. Let's skip all the middle bits. On average, if you were to go from here to here, how fast would you have to go and what direction would you have to head? That's what average velocity is all about. So it's very different from our average speed from earlier. Now, a lot of these calculations are going to be very similar. Squiggly line. What is the velocity? V arrow equals question mark, right? Of a toy that goes 30 meters north, okay? So delta D arrow equals 30 meters north. In 10 seconds, delta T equals 10 seconds. So a lot of these it's kind of the same calculation as we were doing yesterday. So our displacement was 30 meters north. Every time you write a vector, right, with an arrow, you got to have a direction. Divided by 10 seconds. 30 divided by 10 is 3. The problem is this answer needs 2 significant digits. Think to yourself, why does the answer need 2 significant digits? Correct. Absolutely. Because this number is 2 significant digits and this number is 2 significant digits. So we're going to take the lower of the two because we're multiplying or dividing, right? Here we go. So 3.0 meters per second in a northerly direction. So if a toy car went 30 meters north, right? We don't care what it did in the middle, but if it started and finished 30 meters north of where it started, then it would have on average had to go 3 meters every second in a northerly direction. That's what we needed to do. Okay, rolling on through here. A person walks at a velocity of positive 2 meters per second. So that could be north or up or to the right or, to the east, whatever. Squiggly line. So velocity of positive 2.00 meters per second to a bus stop that is located 10 meters away to the east, right? To the east, so they are heading to the east. So delta D equals, I'm going to say positive 10 meters. How long does it take? Question mark. Okay, so V equals delta D over delta T. Remember, shortcut. If we ever want delta t, we just take this thing and we swap places. That is the shortcut. So delta t equals delta d. And if you don't remember how to do that, you can watch the video on rearranging equations. Or watch the video from yesterday, average speed. So delta t equals the displacement divided by the velocity. So positive 10 meters divided by positive 2.00 meters per second. Now you might be thinking, well, why, Mr. Walton, why the heck are you putting in those positives? And that's because both of these are vectors. They need a directional component. The positive, that is the direction, in a positive direction. So we need to include both of those positives. We absolutely have to. And you can almost think of it as like the positive and the positive cancel out, and we get something that isn't a vector. It's complicated. Don't worry about it. That's okay. So 10 divided by 2 is 5. And so when I think about this, okay, I need 3 and 3. So I need 3 significant digits, 5.00 seconds. That's going to be my answer. Moving on up. Not up, but you know what I mean. So a car is traveling at a velocity of 100 kilometers an hour north. So we could say positive if we wanted to. So velocity 100 kilometers an hour north, squiggly line, travels for a period of 2.5 hours, delta t equals 2.5 hours. How far was the displacement for that car? Okay, v equals delta d over delta t. If I want delta d, I got to multiply by delta t, multiply by delta t. So it disappears from the right side. It shows up on the left-hand side. So displacement is equal to v times delta t. So we know what our velocity was. It was 100 kilometers per hour in a northerly direction. And we're going to multiply by how many hours? 2.5 hours. So hours and hours cancel out. And my units I'm left with is kilometers north. So this is going to be 250 kilometers north. Perfect. And if you put that answer, you would be wrong. Unfortunately, you would be wrong. Take a second and think why it's wrong. Correct. Significant digits. Let's take a look at this. This thing has 3 significant digits. This thing has 2 significant digits, and we need the fewest number of significant digits when we're multiplying and dividing. So the answer here is going to be 2.5 times 10 to the 2 kilometers north. Perfect. Ooh, that was better. It's sad that I said that that's better, but whatever, that's better. Okay, so what I want you to do is try some of these questions. There's 4 questions here. Try them out. The key is going to be in the filled out notes. So let me know if you have any problems or any questions. Wednesday, Thursday, Friday, you are given time to register with your connections teacher, but also you're being given time to catch up on whatever it is you need to do. Let me know if you have any questions. Let me know if you want to chat. Otherwise, have a good day and have a good weekend.